congratulations to our cross-country teams who placed very well at the county cross-country match this past Tuesday. Our high school boys cross-country team finished second.
You get finished with the 11 problems, you can lay them up there on the blue chair. They are going to count as a quiz grade. Shouldn't be anything real difficult.
Why did you have to record us like this footage?
You're not supposed to be responding, you're supposed to be listening.
Oh, I know that.
All right, copy this down. You probably won't be able to draw the picture, and that's not a big deal. I'm just going to use it to demonstrate as we go through. Notice line of symmetry doesn't have a definition. We're going to sort of draw in this shape over here and draw in the line of symmetries. You can draw in whatever shape you want to help you remember what a line of symmetry is. Point of symmetry, we'll talk about that when we get to that. That word, isometry, or however you pronounce it, I'm not even sure how you pronounce it. But we'll talk about that also. That they talked about that. That was number 11 on the quiz that you did right at the beginning. What did they tell you that isometry meant? Congruent, right? The two things are congruent. We're going to talk about 4 different transformations throughout this chapter. What's the only transformation that doesn't have isometry? Dilation, where you make something bigger or smaller. Everything else, reflections, rotations, and translations, all have isometry. All right, on this, a reflection. Reflection, another name for a reflection is a flip. This is the part that always confused me. The pre-image and the image. You've got to remember that the pre-image is the original. Probably should be doing this with my pen. The pre-image is the original. So that's where you're starting at. The image is the new. So if I'm taking a picture, of Brian, Brian's the pre-image. Then when I show him the picture, that's the image. Okay? Just keep that sort of straight. Maybe that doesn't confuse any of you guys. It always confused me. Line of symmetry. What's a line of symmetry? What's it do to the shape? All right, splits it in half. Now, you got to be careful, because does it just split it in half? So if I drew, this is your guys' seating chart here. Is that a line of symmetry for this rectangle? No. Why not? It is. Doesn't this triangle look exactly the same as this triangle?
The line's not straight.
Line is straight. All lines are straight. It wouldn't be a line otherwise. So is that a line of symmetry? Why not? Exactly. When you fold this, if I fold this across that line, is it going to match up? No. All right? So that's not a line of symmetry. So you have to be careful where you think lines of symmetry are. This line splits this rectangle into 2 exactly the same parts, 2 exact same triangles, but it's not a line of symmetry. All right? Where would the lines of symmetry be on this rectangle? Straight up and down right through here somewhere?
Yes.
and where else? Straight across this way. All right, so those would be the lines of symmetry for that. Looking at this shape that I have up here, where would there be a line of symmetry? Right down the middle. So you could draw in this line of symmetry. If I could hit everything, that'd be a line of symmetry. Does this side fold over and match up exactly that side? Yeah. Now somebody said corner to corner. What corner?
Every corner.
All right, so that would be a line of symmetry. That would be a line of symmetry. Line of symmetry. Is that all of them? Where else?
You could do the endpoints of like.
You do it in between.
In between where they're concave in, right? So we could do a line of symmetry there. Now, you have to be careful with stuff like that, because just like with the rectangle, in this case, if I fold that over, is it going to match up perfectly? Yeah. A lot of things, when you try to fold over something like that, it's going to be like the rectangle where it doesn't quite match up. So be careful with that. Here, here, and here. How many lines of symmetry are there?
A lot.
A lot's not an answer.
Right, but that is one of the things on that.
Nine.
I heard 8, I heard 16. How come 8 and not 16?
Count all the way around.
Right, because when you counted all the way around, you counted this, then you got over here at this end, and you counted this one. You counted the same line. So there's 8 lines of symmetry there. How many lines of symmetry for this brown shape over here? None.
Maybe.
If I draw this in, is that a line of symmetry?
No.
Now, it looks like this part over here is exactly the same as that part, but is that a line of symmetry? No, because it won't fold. How about if I did that way? Is that a line of symmetry? No, it's not going to quite match up, so that one has 0 lines of symmetry. Let's jump down to this. Point of symmetry. The point of symmetry is going to be where all the lines of symmetry meet. So that's that point right there. That's all point of symmetry is. Something that you probably didn't learn in the past, but it's nothing real difficult. Isometry, again, the pre-image is, what's that symbol mean? Congruent, equal to, the same as the image. So when I take my blue arrow up here and I flip it over the y-axis, I get the red arrow. They're exactly the same arrow, just going different directions.
And a different.
There's going to be like 3 or 4 slides that sort of all look the same, like this right here, that give you the reflection, 2 things here, what we're reflecting it over, and then it tells you how to do each thing. So go ahead and copy this down. I don't know any other easy way to tell you to do it, because it goes this direction, so you can't really extend it out on your paper and just put all of them together. You could try, I guess, if you made it small enough, if you could write small enough to squeeze it in. In other words, there's going to be like 6 of these that we're going to have the coordinates for, and what to do with the coordinates, and how to find each coordinate. Then down here at the bottom on this one, I put in something that's going to make it maybe a little easier for you. All right, these first 2 are pretty easy. These are probably what you learned in the past. You reflect over the x-axis or the y-axis. Nothing really difficult about it. Yeah, you got to know both ways. Most of you are probably used to, when you were in middle school, they gave you a picture, had a shape there, and then you drew the shape where it was going to be when you reflected it.
Yeah.
You've got to know, too, how to take coordinates without seeing the picture and be able to reflect it using these rules. All right? Because a lot of times the book's going to say you have a triangle that has coordinates 2, 3, -7, 4, -2, -1. Do you really want to draw that shape if you don't have to? No. All right? And what you can do if you want to reflect it over the x-axis is just use this rule right here. In the rule, all that happens, we go from AB, this is your x, that's your y, and it switches to A, the opposite of B. So what's this new one going to be? Instead of 2, 3, what's the new coordinate going to be? Does everybody see that? All you do is, for this one, if you're going over the x-axis, you just take the opposite of the y coordinate. What's this new one going to be? -7, -4. How about this new one? If they ask you to find the coordinates of the image, the new shape, did we just find it? Did we have to draw a picture?
No.
No. Would it have taken a lot more work to draw a picture and go through all that and then go back and find the coordinates? Yeah. So if you can use this rule, it's going to make things a lot easier a lot of times. The other thing you could do, if you don't want to look at the coordinates so much, all you're doing is taking the y coordinate and multiplying it by a -1, changing the sign of the y coordinates, all you're doing. If you're reflecting over the y-axis, instead of changing the y coordinate, what's it change? The x coordinate. Now down here I put just count. This is probably what you got used to doing when you did reflections in the past. If I draw a triangle here, and we want to reflect it over the y-axis, probably what you've done in the past is you just took each of these points, each of the corners, and you counted how many spaces it was to the y-axis. And then the new point went over that many spaces on the other side. This one, counted, got 2, go over 2. This one, counted, went over 5. And then you drew your new shape over there. All right? So if it's on a picture, if it's on a graph, then that's probably what you want to do. Just count and see where it's going to turn to. Don't make it harder than it is. Sometimes it's easier to use the rule. Sometimes it's easier to just count. Let's draw a shape on here. Let's use what kind of shape is that?
That is a
There we
good
go.
one.
I'm going to label it with some letters here. So we got A, B, C, D, E, and we want to reflect that. I don't care, pick an axis, X or Y.
X.
X. So we want to go over the X this time. What you can do, you could go through and find all the ordered pairs for each letter. Multiply like the rule just told you. Since it's already on the graph, it's probably easier just to take this and just count. E is how many spaces from the x-axis. So when I flip it down here, that's going to be my new E, except, this is the whole purpose we're doing this, because I know you're getting bored watching this, because you already know most of this. Except I don't just label that E. What do I label it? E with that little mark up there, it's called E prime. Okay? Count for A, 1, 2, 3, 4. 1, 2, 3, 4. That's not going to be A, that's going to be A prime. D is 2 up, so 2 down. That's D prime. C is 2, 4, 6 up, so 6 down. B is 2, 4, 6 up, so 6 straight down. Make sure you go straight down. Our new shape, our image. Remember, this is the image, that was the pre-image. It's going to look like that. And each of the things has a prime with it, a tick mark with it, to show that this is different. Then maybe you want to take this and reflect it across the y-axis. So I want to reflect it over here. Well, D prime was here. So I'm going to put the new D right here. Is that going to be just D prime?
D double prime.
D double prime, very good. Then you do E double prime would be over here somewhere. How far was it? 4. So on, so on, so on. If you wanted to do it again, then it'd be E triple prime. So on, so on. You just keep adding the prime every time you put a new shape on it.
Quintillionth prime.
That's going to be part of Brian's homework tonight.
No.
Not everybody else's, but Brian's.
You just
Oh, I went backwards.
4 times and then just write a bunch of primes on it. Just look like the same place every time.
To the same place every time we come. Oh, you mean if you kept doing it over and over and over again? Well, if we were going to do that, I wouldn't keep doing the same thing over, and that's what we're getting ready to learn now. Something that you haven't learned in the past, probably. Because Peyton's dad didn't think that you were intelligent enough to learn it, so he didn't teach it to you.
Oh, yeah.
I was looking up to see if there was an Optimus symbol in math, so then you can make an Optimus prime. But
All right, go ahead and copy this down. Carefully on this stuff. This is a little tougher because you haven't done this in the past, or maybe you have, and maybe you didn't understand. Brian, listen. We're going to reflect over the origin. With the origin, yeah, we're going to change the origin. The origin is right here. So what you're doing when you're reflecting over the origin, let's say we take this rectangle, and we want to reflect it over the origin, that point right there in the middle of the graph. A lot of you probably in the past have played a game, I got an actual pole looking, tetherball. All right? With tetherball, why is it called tetherball?
Because the ball is tethered.
The ball's tethered to the pole. And that's sort of what you're going to be doing when you're doing this. When you're looking at going across the origin, you're tethering a point to the origin. And then that shape is going to flip, keeping that string or that tether tight to some other part of the graph. Now, probably most of you, maybe you're more intelligent than I am, but when I do that, and I try to do it like you've done in the past, where you say, oh yeah, here, it's going to reflect over here, that's easy to draw. I can't picture that in my head. And I know that Josh probably thinks that he can,
No, I can't.
and he's wrong, because what's going to end up happening is he's going to end up drawing it down here, and it's going to be just a little bit off, or it's going to be a little backwards, or a little turned the wrong way. All right? So with this, you must make sure that you use the rule. You've got to use this rule right here. So what you do, find these coordinates of each corner, and then you just, what's the rule do this time? Makes them both the opposite, right? Now I don't just say negative, because they could start off being negative and then it's going to end up turning into a positive. So if we wanted to take this point, 2, -4. And we want to reflect it over the origin.
-2.
-2, +4. All right? With a point, it's not real difficult. With shapes, you've got to do it to each corner, then graph those 4 new corners, or 3 new corners, or 5 new corners, however many you have, and that'll be your new image. How about this one, y = x? Anybody know what that is? Y = x?
No.
It's a,
0.
it's a line. What form is that in? Anybody remember that from algebra?
Algebraic.
Slope-intercept form.
Slope.
Alright, it's in slope-intercept form, except, it's in slope-intercept form, so I don't want to say except, because it is in slope-intercept form. But what's sort of missing? The b. Well, what is b in this case? 0. What's the m in this case? 1. So it's in slope-intercept form, and it's a line. The easiest way to remember this, y = x, we use that all the time, because y = x, if I draw a graph here, that line is just this line that comes right up through here. It's where x is 1, y is 1, x is 2, y is 2, x is 3, y is 3, x is 4, y is 4. It's that line. So what we're doing is we're taking a shape and we're reflecting it over that line. Again, this is one that Josh, he says, oh, I can picture that in my head. It's one that you're going to mess up. So again, what happens to the x and y? They just switch. They just switch orders. Switch the x and y coordinates. Please, on this one, make sure that you use the rule. You've got to use that rule. Find all 4 new corners or all 3 new corners, then graph it, if that's what they want you to do. But on these 2, you have to use the rules, otherwise you're going to get lost. Because you're going to have some crazy shape at some point. It's going to be something like, and you're going to try to reflect it over the origin, and Josh is going to draw something that looks like that, and it's going to be wrong. You wouldn't do that, would you?
I do it right.
So don't do that.
Like some right.
Both rules. These 2 are a little easier.
Doesn't take me long.
As you're writing this down, first of all, I want to do this. Why is my thing not working? This may happen a lot this chapter, since I usually don't teach this chapter, where I screw up and put the wrong rule in there or something.
It's so messed up. Nick, what the heck?
There will all be others too.
Yeah, economics these days.
If you're reflecting over x equals, what's the symbol mean? A number. So you're reflecting over x equals some number or y equals some number. So it might be something like x equals 4. What kind of line is x equals 4?
Ortho.
Close. Make another guess. Join.
Vertical.
There you go. So this is a vertical line. So you're reflecting over this vertical line. So we have something that looks like this on our graph. That's our graph. And then you have some line. X equals 4 is going to go out here to where x is 4. There's going to be a vertical line in there. And we want to take our shape, whatever it is, and we want to reflect it over that certain line. No real easy way as far as the rule goes. That's why I got rid of this. I followed what the book was trying to say, and I thought, no, that doesn't work, once I figured it out after I typed all this. All you gotta do on this one, find that line and you count how many spaces each point is from the line, then you move it over that many spaces on the other side. Same thing for y equals something, except y equals something, what kind of line is that? Horizontal line, good. It's a horizontal line. And again, just count. Now the bad thing with these two is, if they just give you the coordinates, then what do you have to do first before you can just count? You have to graph it. So on these two, you have to graph it, then count to see where the image is going to be. All right, let's try one here real quick. Let's just do a triangle to make it easy. We'll do that.
That's a straight line. Where's your line?
Here's your line.
Click the wrong thing.
There's your line.
Oh,
All day.
oh, that's unreflected.
What if we were going to reflect that over the y-axis? What would happen?
What now?
And go upside down.
Look like the other, look on the other side of the line.
This point would end up over here. These 2 points would end up on that side. So don't let it confuse you when it's setting on the y or x axis. Let's go with, let's reflect it over, shouldn't have used blue, I don't guess. Let's reflect it over that line. What line is that? Anybody give me the name of that line right there? It's horizontal, so what's it gonna be? Y equals -2, very good. So we want to reflect it over that line. All we gotta do, count. How many spaces is that point from the line? So we go down 4, put a dot. That one's 4 also, down 4, put a dot. How many spaces is that one? 8. 4, 5, 6, 7, 8. Put a dot.
Hey, that looks just like it.
Alright.
That's not much.
So if you're given a line like that, y equals some number, x equals some number, then use that. And you just count. What if we wanted to reflect this shape over the origin? Let's try this, see if we can do this. What's the first thing you need to do if you're going to reflect that over the origin? Oops, that's not the origin.
There you go.
That's the origin. Not that one.
Do the slope intercept.
I swear to God, his silver says find the coordinate.
You gotta find the coordinates. Somebody help me out, what's the coordinates of this one?
Negative
-6.
6 and 2.
I'm gonna have to start saying answers like a lot in here are gonna get you in a lot of trouble, aren't they?
1 and 2.
1 and 2.
Dude, my stomach.
How about this one?
A lot. -3, 6.
Oh, and when I said a lot of trouble, I meant it's gonna get you detention if I hear it again.
What, a lot?
So any answer along that smart aleck line.
Okay.
What was that, 6? Now, what do you do with those to go over the origin? What was the rule? AB goes to what? BA? Is that origin?
-8. No, you just most of negative. I guess a negative.
Negative A, negative B. All right. So what's this new one gonna be?
6, -2.
let's do this, give me a second. I can change the color here. Let's do green. What's this new point gonna be?
6, -6.
6, -2, what's this new point gonna be?
3, -6.
3, -6, how about this one?
-1, -2.
-1, -2. Then regraph all those. 3, -6. Gonna be right there. -1, -2 is gonna be right here. And then,
That's at -1, -4.
We don't have negative one, negative four.
where do you see that?
The point that you just put.
Oh,
Is at -4.
-1, -2, I keep going back to this stupid line right here that I drew in. So we got that, get rid of that. And then, what's the other one, 6, -2. 5, 6, -2. So even though, I did this one wrong, I didn't go down enough. Even though Josh said that he could picture that, I can't even draw it right. He can picture it in his head though, without going through all that. That's what it would look like if you reflected that over the origin. Of the scrap paper, you can do this on the scrap paper.
Oh.
You're gonna hand this in before you go. If you wanna grab a new sheet of scrap paper, you can grab one up there.
What? Thank you.
Right, I'm not going all the way back there.
Oh, he's so recording that.
If you get finished with this, you can lay it on the blue chair. Lay it on the blue chair. This is tonight's assignment.
You're still recording.
That's right. This is tonight's assignment. If you need graph paper, there always is graph paper laying over here. So when you do your assignments, don't take a big stack of it because I got to run it off, all right? Take 1 or 2 sheets. You can use it for the assignments. There's 2 different kinds of graph paper. One has like 12 little grids on it. Sometimes that's better for an assignment because then you can do different problems on each one. Sometimes you need the bigger grid because it goes up past, 8 or 9 or something like that. So you might need the bigger graph paper. But if you need that, you can use it. If you have graph paper at the house, then it'd be extremely helpful to me so I don't have to run off a bunch more copies all the time if you use your own. Again, the assignment is over here on the side. Once everybody has this, the assignment's also on the PowerPoint. But I don't want to switch to it right yet because people are still... Don't move yet. I got your test up here. I want you to do that. On Moodle. We were going to do it and I completely forgot about it. We were going to watch one of the videos. I was going to have you watch one of them. On Moodle, if you go to today's date, there's 2 videos. Watch those 2 videos. Then right after the videos on Moodle, there's a little short quiz. By Friday, watch the 2 videos. They're only 3 or 4 minutes long or something like that. Watch the 2 videos, take the quiz, and that quiz grade will drop directly into Moodle. That's got to be done by Friday. All right? Also, you can sort of keep those. I'm going to have Nick grab his. You can add your homework right to those papers if you want, so that, because I don't feel like reading. I'll do it with your homework. Your test, I'm handing back your test.
Dude, no, I don't want to touch mine.
Again, if you want to rework the stuff on your test, then rework it. You make sure you show this to Mr. Fisher, all right? Because he's probably sitting in here thinking, man, Mr. Ersell's picking on Austin. That's not very nice.
You got 100. When did you go? That was
Yep.
yours.
100.7.
What did I get?
You missed
Did I
one
get a higher
bonus,
grade
I did.
than you?
I think so.
I didn't go for the
Yeah, this one does.
Only Austin.
I just
Oh.
gave up.
Hey,
Austin, I bet I got almost 40%.
Yeah, you can.
pretty good.
That's great.
Again, so do next time quiz, Make sure you're getting that done. Make sure. I was probably wrong. It wasn't 6 people got hired than you. I was thinking you got like a 104. I think there was, you got 107.
Wait, you got 107?
Yeah.
I think there was only like 2 or 3 people got hired than you.
Wait, what bonus did I miss?
You didn't miss anything. You got them all.
Bro, I thought you got 187.
I got 100.
You got 111.
Oh,
You got
yeah.
111. So you got that one bonus. You got the triangle right here.